Welcome to Oilfield Academy, your source for smart, practical oilfield skills. Let's power up your knowledge.
Hey everyone, and welcome back to the channel. If you're involved in the oil and gas industry, you know that drilling a well is just the beginning. The real challenge, and the real money, is in keeping that well productive over the long term. Today, we're diving into a critical topic, well intervention. It sounds complex, but it's really the maintenance and tune-up work we do on a well to keep the hydrocarbons flowing. By the end of this video, you'll understand what it is, why it's necessary, and the basic tools we use to get the job done. Let's get started. Let's start with a clear definition, straight from the industry. Well intervention is essentially any operation performed on an oil or gas well after it has been drilled and completed. Think of it as well maintenance or, if things go wrong, well surgery. The goal is always to address an issue downhole, and this can happen at any time, throughout the well's productive life, or even at the end of its life. We intervene for three main reasons. To improve production performance. Maybe the flow is dropping, and we need to clean something out. To extend the production life. We want that well to produce oil or gas for as long as possible. To change the condition of the well and well integrity. This means making sure the well's physical structure is safe and functional. The key technical takeaway here is the difference between drilling and intervention. Drilling is creating the hole. Intervention is working inside the existing pipes, or the tubing and casing. Now that we know what it is, let's look at the primary drivers. Why does a well need this attention? Slide 2 breaks down the main reasons into categories. 1. Production decline and well stimulation. Sometimes, the flow of oil or gas naturally slows down, known as production decline. We can counter this with well stimulation. This could be hydraulic fracturing or acid stimulations. These are major operations designed to create or dissolve flow paths in the rock, essentially giving the oil or gas an easier path into the wellbore. We might also use artificial lift methods, like installing or retrieving gas lift valves, GLVs, or a jet pump, to help a struggling well. 2. Well integrity issues. A well is a high-pressure environment, and pipes can get damaged. We need to maintain well integrity. This includes tasks like casing and tubing repairs or installing plugs for X-tree repair. The X-tree is short for the Christmas tree, the collection of valves at the wellhead. 3. Well evaluation and cleanup. A major issue is the accumulation of debris, like sand or scale, which reduces the flow. We intervene to remove these blockages. We also perform well evaluation. This is when we run logging tools, like a production logging tool, PLT, or tools to measure pressure and temperature downhole. This evaluation tells us where the fluid is coming from and how much is being produced, which is key to planning the next steps. The key to evaluation is gathering the data. For example, a PLT measures flow rate, water cut, and temperature along the wellbore. If we see a sudden increase in water cut, the percentage of water in the produced fluid, we might decide to perform a water shutoff to block the unwanted water source and save money on treating all that fluid. So, intervention is not just fixing things, it's also data gathering to make smarter production decisions. So how do we get those tools thousands of feet down the well? The most common and versatile method is wireline. This is basically a line, or a thin cable, spooled onto a drum on the surface that carries a tool to the bottom of the well. Wireline itself is broken down into a few categories. Slick line. This is a solid, smooth metal wire. It's strong and reliable for simple mechanical operations like setting plugs, removing scale, or running smaller measuring devices. Tools are deployed using gravity and retrieved by pulling the wire. The only way we can actuate a tool is often by mechanical jarring. Braided line. This is a cable made of multiple twisted strands, which makes it stronger and more resistant to rotation. Its main use is for operations that require significant pulling force or tension, like fishing for lost equipment downhole. Electrical line, or E-line. This is where things get advanced. E-line has electrical conductors inside the cable. This allows us to transmit electrical signals and power from the surface to the downhole tool. This is essential for sophisticated electronic logging and perforating tools, giving us real-time data. Digital slick line. Slick E-line. This is a newer, hybrid technology that gives you the mechanical strength of slick line, but with an electrical conductor for digital data transmission. It can combine mechanical jarring with an E-signal. Coiled tubing. While not a wire, it's a major intervention method. This is a continuous steel tube spooled on a massive reel. The advantage? We can pump fluids through the tube for things like acid stimulation, cementing, or cleanout operations. It's used for heavier duty tasks like recompletion. The key difference between slick line and E-line comes down to communication. Slick line is a mechanical operation. You can only pull or drop a tool. E-line is a data operation. You can talk to the tool, get real-time information, and command complex functions, which is crucial for modern reservoir management. So, understanding well intervention is fundamental to a long and healthy life for any oil or gas field. If you found this breakdown helpful, please hit that like button and subscribe for more simplified technical lessons. Let me know in the comments, which wireline method do you think is the most cost-effective? Thanks for watching, and I'll see you in the next one.